Hello, this is Catherine Morgan-Nance. In this video, I'll show you how standard cost systems account for fixed manufacturing overheads. We will define the denominator activity, then consider how fixed manufacturing overhead is applied to actual production using standard costing methods. We will also look at the two fixed overhead variances, the budget variance and the volume variance. When we've discussed the predetermined overhead rate, the POHR, in earlier chapters, we've defined the POHR to be equal to estimated total manufacturing overhead cost divided by the quantity of some estimated total allocation base. The allocation base has usually been direct labor hours or machine hours. When standard costing is used, the allocation base is referred to as the denominator activity. For example, if total overheads are estimated to be $360,000 and the company expects to use 90,000 machine hours, one would calculate the predetermined overhead rate to be $4 per machine hour. And as you recall, the POHR is estimated before the beginning of the company's fiscal year during its budget process. You've also learned that manufacturing overhead cost is comprised of fixed and variable components. The fixed part may include factory rent, insurance, and depreciation, for example. We refer to fixed cost as being constant in total, $50,000 per month in rent, for example. And the variable part of overheads would include indirect costs that vary with production. Examples might include grease and oil, shop supplies, some indirect labor, and so forth. We generally talk about variable cost in terms of how much they cost per unit of activity. We can express total manufacturing overhead in terms of fixed and variable cost by using the equation y equals a plus bx, where y is total manufacturing overhead, a is the fixed portion of overhead, and bx is the total variable cost. Recall that b is the variable portion of the POHR, and x is the quantity to be used of the denominator activity. Likewise, we can also break the POHR into fixed and variable portions. We talked about the variable POHR, the VPOHR, in previous videos. Estimated fixed manufacturing overhead, then, divided by whatever the estimated total denominator activity is, will yield the fixed portion of the POHR. The remainder of this video will focus on how the fixed POHR is calculated and how it's used in standard costing. Let's consider an example of how to compute the fixed and total POHRs. Here are the facts. A company expects to produce 90,000 units. Manufacturing overhead is applied based on machine hours. It should take 1 hour to make 1 unit. The variable POHR is $1 per machine hour, and total budgeted fixed manufacturing overhead is $270,000. And here are my requirements. How much is the total denominator activity level in the budget? How much is the standard fixed POHR, and how much is the total POHR? Machine hours have been identified as the denominator activity for all overhead application. If the company uses 1 machine hour to make 1 product, then it should take 90,000 machine hours to make 90,000 units of product. 90,000 machine hours is the denominator activity level. The fixed POHR is computed by dividing fixed overheads of $270,000 by 90,000 machine hours for $3 per machine hour. If we wanted to know the total POHR, we'd simply add the fixed and variable POHRs together to get $4 per machine hour, $3 plus $1. Notice that we're saying that 1 unit of product will take $3 of fixed overhead. $3 is the standard fixed manufacturing overhead cost per unit. This is computed by multiplying 1 unit times 1 machine hour times $3 fixed POHR per machine hour. Please keep these facts in mind as we move through the remainder of the presentation. As we saw in our video about job costing, where we used an actual costing system, overhead is applied to work in process inventory there on the basis of the actual activity level of the allocation base used by each job. However, in a standard cost system, overhead is applied to work in process inventory on the basis of the standard hours allowed for the actual quantity produced. In our example, the company is allowed to work 1 machine hour for each 1 unit of product produced. Using what we've learned so far, how much would total standard cost be for fixed manufacturing overhead if we produced 95,000 units? As noted a moment ago, the concept of applying overhead in a standard cost environment is similar to what we've learned in the job costing environment. Here, we're allowed to work 1 machine hour for each unit produced, or 95,000 standard machine hours are allowed because we produce 95,000 units. And we are allowed to spend $3 per machine hour. Therefore, the total standard cost for fixed manufacturing overhead for those 95,000 units is equal to our standard quantity, that's 95,000 machine hours, times our standard rate of $3 fixed POHR, or $285,000. In this next section, we'll learn how to compute and interpret the fixed overhead budget and volume variances. Fixed overhead variances are different than others shown so far because of how fixed costs behave. Fixed costs are constant in total, regardless of activity. In fact, regardless of how much you produce, as long as you're in the relevant range, you would hope that your actual costs are equal to your budget. And here's where things get interesting. Remember, with standard costing, inventory produced is valued at standard cost. So we are going to compare our actual fixed cost with the standard cost allowed and determine a total fixed overhead variance. In this case, let's assume our actual spending was $310,000, and as we computed previously, we were allowed to spend $285,000 based on producing 95,000 units. We determine our overall variance like we've done previously. In this case, it's an unfavorable variance of $25,000. That's $310 actual minus $285 standard allowed. But wait, fixed costs are supposed to be $270,000 no matter how much we produce, right? Because they're fixed in total. How come we're not just comparing actual costs to the budget? Well, companies address this issue by breaking the total variance into the budget variance, which is related to spending, and the volume variance, which measures how efficiently the production facility is used. So let's talk about the difference between our actual spending for overhead and the amount of overhead we thought we'd spend in the budget. We call this difference the budget variance. The equation for computing the budget variance is shown on the slide. It is simply the difference between the actual fixed manufacturing overhead and the budgeted fixed manufacturing overhead for the period. To deconstruct the concept of the budget variance, just consider the following. When you build your budget, you should have a pretty good idea of how much your rent and insurance and salaries and other fixed costs are, right? If you have a difference between actual and budgeted fixed overhead, you'd want to explain it, because you really shouldn't have much of a difference. That is, if your budget was a good one. Here, we assume actual fixed manufacturing overhead was $310,000, and our budget said we'd spend $270,000 for fixed overheads, so we're not looking very good. We spent more than we planned to on fixed overheads, so the budget variance is $40,000 unfavorable. That's 310 minus 270. And next up is the volume variance. The volume variance. And here's where things become even more interesting. This variance has nothing to do with rate. It only tells us about levels of production. Remember, with standard costing, inventory produced is valued at standard cost. And if you recall, the budget is where we first determined our standard cost. So when we produce more than we budgeted for, we end up with the equivalent of overapplied overhead in total. In our example, the budget said we should make 90,000 units for a total fixed overhead cost of $270. Instead, we produced 95,000 units with a total standard overhead cost of $285. That's 95,000 units times 1 machine hour per unit times $3 fixed POHR. Please refer back a few slides if you've forgotten how we got to these numbers. The 15,000 difference between these last two amounts is related only to the level of production. It's related to the 5,000 units times 1 machine hour per unit times the $3 fixed POHR. When the total standard cost applied to inventory is higher than the budget, it simply means that we used our production facility more efficiently than we planned. We got more units of production than planned out of a fixed cost resource, and that's a good thing. Thus, the $15,000 volume variance between the static planning budget of $270,000 and the overhead applied of $285,000, that volume variance is favorable. To summarize then, a volume variance occurs when the actual level of production differs from the budgeted level of production. The volume variance has nothing to do with rate. It has only to do with the level of production. It is the difference between the total budgeted fixed overhead and the total fixed overhead applied to inventory produced. If we produce more units than planned in the budget, we utilize the factory more efficiently than we planned, so the volume variance will be favorable. If we produce fewer units than planned in the budget, we did not use the factory as efficiently as we thought we would, so the volume variance will be unfavorable. We'll consider the following scenario. ABC Company has a standard cost system which applied overhead to products based on standard direct labor hours allowed for the actual output of the period, that's the actual production. Data concerning the most recent year appears below, and here are the facts. The total budgeted fixed overhead for the year is $250,000. The actual fixed overhead for the year is $254,000. Budgeted standard direct labor hours are 25,000 hours. Actual direct labor hours are 27,000 hours. And standard direct labor hours allowed for the actual output are 26,000 hours. Consider pausing the video for a few moments to compute the following bits of information with the facts I gave you on the preceding slide. First, compute the fixed portion of the POHR, then compute the budget variance and the volume variance. So how'd you do? To compute the fixed portion of the predetermined overhead rate, we divide the budgeted fixed overhead of $250,000 by 25,000 budgeted standard direct labor hours for a fixed POHR of $10 per direct labor hour. To compute the budget variance, simply take the difference between the $254,000 in actual fixed manufacturing overhead and the budget of $250,000. Because we spent more than our budget, the $4,000 budget variance is unfavorable. On the other hand, we have a favorable volume variance of $10,000. The standard fixed manufacturing overhead applied to inventory is based on 26,000 standard direct labor hours allowed times a fixed POHR of $10 or $260,000. We thought we were only going to work 25,000 hours or $250,000 worth of budget, so our production must have been higher than the budget because the standard hours allowed are higher than the budgeted hours. Therefore, the volume variance is favorable. Good job, you guys, sticking with me throughout this video. And that's all for now. See you later.